For this video, I'm going to go over a concrete example of an array Numpy manipulation. And the reason for that is because, there's so many Numpy functions out there, and a good way to kind of get a general sense of them is to, watch a course maybe, or go through all the Numpy functions and, what they do, maybe look at just the most popular ones. But until you actually work through concrete examples, you don't really get an idea of a true understanding of where to use them and how to use them and how to, make steps for what you want to produce. Given some number of arrays, what array you want to produce with them, and then to apply the functions to each of those steps. So this is an example that I went through for a project I'm working on, and if you're interested, it's to do with constructing a neural network from scratch with derived backpropagation equations that are constructed from scratch as well. You can imagine with a neural network, if you're familiar with them, that they have a lot more parameters, so this is a more simplified version of it, but the premise is the same. If neural networks don't really make sense to you, then that's fine. It's not the point of this video. The point of this video is to go through a specific example. Anyways, this is the example. So these two arrays here, A and P, those are the arrays that we're given. They're two-dimensional arrays. And we want to produce this array here, which is a combination, a manipulation of the two arrays that we're given. So what I'm going to do is I'm just going to write these two arrays here so you can see the format. And there's P. So if we print those two, we can see that those are the arrays anyways, and they correspond to these two here. And then we want to produce this one in the end, which is a combination of the two. There's some things to note about this one before we get to the steps and how to do it. Firstly, it's three-dimensional, so there's an added dimension. Secondly, if you look at the elements in this top section here, the terms, they only contain the elements from the first columns of these two arrays. And in a similar way, this bottom section here only contains elements in this second column of both of these arrays. It also looks like this first column is transposed here along the row, and it's repeated 3 times. And then the second column is down here in the same fashion. It's transposed and then repeated 3 times. Another thing to note is this column here appears here and then repeats along the row, and in the same way the second column is over here and repeats along the row. So these are just some things to note, and we'll kind of think about this while we're deriving the steps for how to construct this with these two arrays. I will just go over quickly how I'm going to refer to the axes. Now, I think that this is how Numpy wants us to refer to them. When you put in the axes in the Numpy functions, it corresponds with the way that I'm going to refer to them. So I think that this is the way that Numpy wants us to refer to them. So this is the way that I'm going to refer to the axes in the arrays. For example, given this two-dimensional array here, A, the column, which is corresponding to this outer bracket here, is axis 0. And then the row, which corresponds to each of these inner brackets here, is axis 1. And it's the same premise for the P. Now, once you get to a higher dimension, the most outer bracket is still 0, but this time it's not the column, it's each of these 2D, corresponds to each of these 2D arrays here. So this top section here and the bottom section here, that's axis 0. And then the column is now axis 1, and the rows, each of the individual rows, are axis 2. Alright, now that I've gone over how I'm going to refer to the axes, let's continue on with the rest of the manipulation. So the first step here, I'm going to move this up here, is that I want to separate out the A's and the P's from this array that we're going to produce. this array here is the same as this array down here. So I've just copied it over. And what I've written here is that this array equals this array of A's multiplied by this array of P. And when I say multiply here, which is this asterisk, I mean element-wise multiplication. So all I've done is I've taken the left terms in all of these elements and I've separated those out, and those are all A's. So I've separated them out to an array of A's, and then I've separated out the right term, which is P's, and I've separated that out to an array of P's. So if you look at these two arrays here, you can see that if you multiply them element-wise, you get the same array here which we want to produce. So for example, A5 here times P2 is A5 times P2, and that's the same as this. A7 times P4 is the same as A7 times P4, and it's in the same spot as these two. Now the reason I've done it this way is because if you remember up here, the arrays that we're given an array of A's, an array of P's. So if we use this array of A's and we construct this modified array of A's, and if we use this array of P's and we construct this modified array of P's, and simply we can just perform element-wise multiplication, element-wise product, and we can get the array that we want. Okay, well, all the elements here in this modified array of A's are the same as the elements here. So we can kind of combine them in such a way, manipulate them, use Numpy functions to get what we want. And that's what we're going to do essentially. So that's what I've written here, is that we want to produce this array here from the array that we're given. And likewise, we want to produce this array from this one, which we're given. That's the same thing I've written here, and it's just highlighted here. So we want to produce this modified array of A's from the array that we're given, and the same for the P's. We're going to start with the A's. It's actually turns out to be harder with the A's, but we'll get that over with, and then P's will be easy. So these are the steps that we're going to take. What I did when I was trying to figure out how to do this was I just tried to think about how to do it intuitively. I am sure that this is not the only way to go about this manipulation because there's so many Numpy functions out there, but it's the way that made sense to me when I was kind of thinking it out. So if you start with this array here and you figure out yourself what makes sense to you to get to this array, and that makes more sense to you, then do it that way, you know. But I'm just going to go over the steps that I took. And what I was doing when I was kind of thinking about how to go about these steps, so I kind of thought to myself, okay, what function might Numpy have reasonably, rationally to, manipulate arrays? And that's how I created these steps. Like, for example, Numpy probably has a function to expand the dimensions of an array. So I made one of the steps to expand the dimensions of an array. Numpy probably would reasonably have a function to repeat certain axes a certain number of times. So that's one of the steps I took. So you kind of have to think about, what Numpy, if you don't know the functions super well, that's the way that you got to kind of think about it. And then you can just Google from there, and I'll show you how to really do that. Anyways, so we start off with this array here, and we want to get to this final one here. These are the steps that made sense to me. Firstly, note that with this final array, there is an added dimension. So with this first step here, I added a dimension. That's all that I did to get from this first array to this second array. I just added a dimension. Now, the next step, I note that this top section here, which corresponds to the 0th element in axis 0, only contains elements from A that are in this first column here. And now the first column that corresponds to axis 1. And then the section down here, which is the first element of axis 0, and I say first because we're starting at 0 with the way that Python indexes, that only contains elements from this second column here. So this second step here, I have taken all the elements in this first column and moved them in this top section here, which corresponds to the 0th element in axis 0. And this second column, I've moved it down here. So essentially, it might look a bit confusing as to, what really the difference is. I've just moved it up here, and now the brackets have changed a little bit, but really all that's happening here is we're switching the axes around, so A1 and A2 are now here, A1 and A2. That is within a different axis. This is within axis 0 now because it corresponds to this outer bracket here. Hopefully that makes sense. It should make sense when we start coding the functions. The next step, which is from here to here, is that I've noted that with this array that we want to construct, the columns here have transposed to the rows. So here we have the column A1, A4, A7, A10, and that column is now here on the row. And then it's the same idea for the second column here, A2, A5, A8, A11. That's moved here to the row. So to get from here to here, I have transposed the columns to the rows. And again, this is another movement of axes. It's transpose, which is essentially in the same group as swapping axes around. And then all that's happening here is we're just repeating it 3 times along the columns. So here is A1, A4, A7, A10. There's that one, and we're just repeating it 3 times here along the columns, along the first axis, because it's still within these brackets here. And then it's the same idea for this second part here. That gets repeated 3 times. So let's get started. I'm going to move this down here, put more spots. All right, so we start with this array here. Let's move this down here. We have A. The first step we want to take is to expand the dimensions. And maybe you don't know what function there is for that. An easy way to do it is just to type in numpy add dimensions to array. And then it comes up with a function that probably does what you want to do. And it's expand dims. And looking at the title, it looks like that's exactly what we want to do. And then if you read it a little bit, you see you pass in an array and then you pass in an axis to expand the dimensions on. So let's give that a shot. Let's say numpy.expand dims, and then the array is A, and we want to expand it along axis 0 because that's the most outer one. We want to add 1 to the end here. And you can see that we get the same array here. So this worked, and therefore we can add it to the step here. Now, the next step, what we want to do is we want to get from here to here. Now, again, I was saying that this is kind of moving the axes around because we've got the first column here and, well, actually not the first column. We've got the first row here and we're changing the axes that they are. So instead of being along axis 2, they are now along axis 0. And the same as this one here, A4 and A5, instead of being along axis 2, they are along axis 0, which is the most outer axis. The axis that makes it 3D, essentially. So, we go numpy, change axes. And then we get a numpy function. We get 3 actually, and they're all on the same page. I'm going to use swap axes here. Interchange two axes of an array. Let's give that a shot. We have the array and then the two axes to interchange. So numpy dot swap axes. Let's try axes 2 and 0, and we get what we want. Now I know that we got to interchange 2 with 0, and if you look at it carefully, it'll make sense, and then you'll write that down. But when I first did it, I knew that I had to use the swap axes command somewhere, but I didn't really understand how to use it very well. So honestly, it was trial and error. I tried probably 1 with 2 or 0 with 1 or whatever. So trial and error. You kind of know that you have to swap axes around, or you might know. So give that a shot and then try different ones until it works. And then once it does work, you rationalize it. You think, okay, now from this new understanding that this is what the result is, maybe I can read the documentation and now I can understand what the documentation is saying. And this is what I mean by the documentation, the Numpy guide here. Anyways, so we've got what we wanted. We switched axis 2 with axis 0. And now we want to get to this array here. Actually, first I'm just going to write this like this. 820. All right. If you look at this carefully, you'll see that this is another swap axes. We're changing the axes around again. We are changing the columns and we're changing them to the rows. That is a swap axis of column to row, which is 1 to 2. So we can go numpy dot swap axes and then column to rows. And that's what we get. So we can write that here. And then finally we want to get to this array here, and what we're doing is looks like we're duplicating the rows 3 times along the columns. So we start with this row here and we're duplicating it along the first axis, which is the columns, and the same for this second row here. How to duplicate rows. And we get a couple of functions here. Let's take the first one, which I know is the one that we're going to use anyways. So we got the array here and we repeat it a certain number of times along an axis. That is the way that it works. And obviously when you're doing this at first, you read through it, but I know that that's the way that it works. So yeah, it tells you here, we take in a number of repetitions and the axis along which to repeat values. So we can write numpy dot, repeat. Now repeating it 3 times. It's by a factor of 3. That's why we write 3 and not 2. It's not adding 2 more times. It's by a factor. And what is it? It's along the columns. I think that's the way that we put it. Yeah, that is the way that we put it. So it's not actually the axis to repeat. It's the axis through which we are repeating. And that is the final manipulated array that we want. So that is the result. And what we can do is we can chain together these functions just to make it a bit more neater. Well, not neater, but just a bit more consolidated. So, I don't know, A manipulated is, okay, so firstly we expand the dimensions. And then to that result, we swap the axes. And that's the same as this one here. And now to do the third line here, we swap the axes again to that result, and that's 1 with 2. And then now for the final row, we repeat to that result, which is the same as A in this case. We repeat 3 times along axis 1. And we get A manipulated, and I'll just make sure that that is the same result. That is the same result. We have got our first array. You can write it up here. Now we want to do P. And I'll show you the steps for P. So we can get rid of this and smooth this up there. Now we've got P here. So we have this first array here, which is the P that we're given. And then we want to produce this modified P manipulated array. And this one is a little bit simpler from the way that I did it anyways, compared to A. Firstly, note that it has an added dimension, so we expand the dims, expand the dimensions or axes. Then it looks like with the same idea for A, we move the axes around, so the rows are now moved along axis 0. The rows, which is axis 2, are now moved along axis 0, and the same for this one here, P7, P8. Then finally, all we're doing is repeating 4 times. We're repeating these columns here along the rows 4 times. So we can use the exact same functions that we've used above. So P is expand dims, and that is still axis 0. I wonder what would happen if I put axis 1. Yeah, so it's not the same thing. So it adds an extra axis somewhere else. So let's put 0. Then we want to do the same process as we did for A, which, if you remember, it was, what was it, swap axes and axis 2 with axis 0. And then print that out. Yep. And now we still use the repeat function, but it's a little bit different now. We repeat it with a factor of 4, and we repeat it along the rows. Because here we're repeating the column, but we're repeating it along the rows. And the rows is axis 2, because this is a 3-dimensional array. So the 3-dimensional part, that's axis 0. The column is axis 1, and then the row is axis 2. So repeating it along the row, which is axis 2. And then we get this final result here, which is exactly what we want. So I'm just going to write it in one chain here. Okay. So then if we print out P, we get the same result. And now we have everything that we need, really. So we can move this up at the top. And let's call it P manipulated. And then to get this final one here, let's move this there, and then there we go. So we have A and P here. A manipulated that we've constructed is this array here. And then P manipulated that we've constructed is this array here. So all we need to do to get the final array is we just take the element-wise product of the two. You can print it out. And what have I done? Okay, let's look at this. All right, I know what's happened now is that because P isn't defined here, we ran it twice on P, and that's why we got this weird array here. So I need to actually move P up to the top. So I need to move this up here. And now we reset A and P, and then we apply these once. And if we run that, we don't get an error this time. So we print final array, that's what we get. And I'm saying that that's equal to this. We can test out if this actually performs element-wise. Let's do that. Or actually, what we want to do is we'll put it on the same line here. All right, so we have A manipulated and we have P manipulated. Now let's just confirm that it performs element-wise product. So we have 1 times 1 is 1, that's fine. Let's say we have 10 times 1, that's 10. We have 4 there times 4, that's 16. 11 times 5, where's that, is 55. So it does perform element-wise product. So yeah, that works. And to recap, we started with these two arrays here, A and P. And then using these two lines that I've written here, we manipulated them to become this array here for A, and then this array here, which is modified P. So this is modified A, and this is modified P. So all we do then is just perform the element-wise product, and we get the final array that we want.